Hi, this is differentiation of polynomials with roots. The formula for that is if y equal to ax to the power of n, then dy over dx is equal to anx to the power of n minus 1. Here in this case, you can see that the equation is p equal to 5 cube root of q minus 9 over square root of q to the power of 5 plus 15q. So we first need to convert each of these roots into a normal index. So we know that cube root of q is equal to q to the power of 1 over 3. Similarly, square root of q to the power of 5 is equal to q to the power of 5, and the square root is half, therefore it is q to the power of 5 over 2. Now using this, in this equation you have p is equal to 5 q to the power of 1 over 3 minus 9 q to the power of 5 over 2 plus 15q. Now we can see that the formula supports the variable in the numerator. So this variable which is in the denominator has to be moved to the numerator. We already know that q to the power of 5 over 2 or minus 5 over 2 is equal to 1 over q to the power of 5 over 2. The reason being, the index which is positive in the denominator will become a negative when it is moved to the numerator. So applying this change in this equation, we have p is equal to 5 q to the power of 1 over 3 minus 9 q to the power of minus 5 over 2 plus 15q. Now to substitute the values into the formula to start the differentiation, it is ideal that we know the values of a and n first. So the value of a for the first term is a equal to 5 and n equal to 1 over 3, and for the second term it is a equal to 9 and n equal to minus 5 over 2. In the third term, a is equal to 15 and n equal to 1. Now substituting the values of a and n into the formula, dy over dx is equal to a n x to the power of n minus 1. We have dp over dq, which is equal to a is 5, n is 1 over 3, n to the power of q to the power of 1 over 3 minus 1 minus 9, which is a, n is minus 5 over 2, q to the power of minus 5 over 2 minus 1 plus 15 is a and n is 1, q to the power of 1 minus 1. 5 times 1 over 3 becomes 5 over 3, q to the power of 1 over 3 minus 1 is minus 2 over 3, minus 9 times minus 5 over 2 is plus 45 over 2, q to the power of minus 7 over 2 plus 15 times 1 is 15, q to the power of 0. Now you can see that all these variables which have got negative index can be made positive by moving the variables in the numerator to the denominator. Therefore we have 5 over 3 q to the power of 2 over 3. Therefore the power which was negative in the numerator becomes a positive, and in the same way the power which was negative in the numerator will become a positive, which will become q to the power of 7 over 2 plus 15, because q to the power of 0 equal to 1, 15 times 1 is equal to 15. Now q to the power of 2 over 3 is equal to q to the power of 2 times 1 over 3. 2 times 1 over 3 means 1 over 3 in the power means cube root. So therefore it is cube root of q square. And also q to the power of 7 over 2 is equal to q to the power of 7 times 1 over 2. Therefore, because it is q to the power of 7 times half, half means square root when it is in the power. Therefore, it is square root of q to the power of 7. Substituting these two answers into the final equation, we have 5 over 3. Q to the power of 2 over 3 can be replaced by cube root of q squared. So it is cube root of q square plus 45 over 2. Q to the power of 7 over 2 is square root of q to the power of 7 plus 15. And the differential coefficient is dp over dq because you are differentiating the equation p with respect to the variable q.